Hello everyone, this is Mustafa Al-Naimi and I'll be presenting our final project for the graduate level course Embedded System class at Wayne State University, ECE 5620. We are 3 people in this group, myself, Matthew Hagen and Brian Yusuf Dukhl. Due to the COVID-19 situation, we couldn't get all of us together, so I'll be presenting the project myself. Our project basically is about designing a weather station using EtherCAT communication. Now, what's EtherCAT? EtherCAT, it's an Ethernet-based high-speed real-time communications protocol. EtherCAT is used in servo drive and time-critical applications. Also, it's used in test and measurement systems. The EtherCAT goes up to 100 megabits per second maximum throughput, and it has a benefit also of a minimal stack delay that could run a 100 microsecond cycle loop. For our topology, the EtherCAT is a master-slave protocol, so we will have a master and 2 slave devices. We are using basically a linear topology which has 2 daisy-chained slaves connected to the master controller. I'm going to give a quick high-level description about the controllers we are using. For the master, we are using the TI AM3359X, which is an ARM-based architecture, A8 core, and it has a 24 megahertz clock frequency. For the slave devices, we are using the Infineon XMC4800, and also it's an ARM-based architecture, Cortex-A8, and it has a 144 megahertz frequency clock. Also, the slave devices comes with a PHY card that comes with the microcontroller itself. This PHY card has the physical interface for the EtherCAT that you could use it to communicate with another slaves or master in the EtherCAT network. Also, we assembled a PCB with 4 sensors. The sensors will be connected to the analog interfaces on the slave devices, 2 sensors per slave, and those analog interfaces will be mapped to the PDOs, which are the process data objects, the cyclic messages that will be used to basically collect all the measurements in every cycle. Our applications will run at 5 milliseconds time, so it's pretty fast in terms of real-time communications. Basically, in terms of the software design, we are using the SOEM, which is a simple open source library that has all the necessary drivers that will be establishing the EtherCAT Master network on the network interface on the controller. And we designed our applications that will basically interface with the SOEM. The master controller, it is installed with the real-time Linux systems that runs from an SD card. Our applications is running on that Linux systems and will be interfacing with the slave devices. For the software design of our applications, basically the application will discover, initialize, and configure all the slaves in the network. Based on successful initialization, we'll create 3 threads. The main thread will be the communication thread that will be collecting all the measurements every cycle, and that thread is running at 5 milliseconds. Also, we have 2 lower priority threads. One is to monitor and check for errors regarding the state machines in case of one of the slave will go into a bad state, or if any of the slaves lose synchronization or some problem happens in the application itself. Also, we have another lower priority thread which will take care of the printing. We'll be printing all the measurements on the screen. As in terms of the demo, I'll be running our applications. So as you see, the network is already up and running. Measurements are taking place on the output screen. You see the changes are already reflected on the LEDs. Also, you see the run LED for the slave device. That means all the slaves are in the operational mode. and basically those LEDs will be reflected by the light sensors, those will be reflected by the temperature. So basically if I give an intense light, you see the reflection for the LEDs, and also if I dim the light sensors, that will also reflect the LEDs in a real-time mode. For the thermistors, basically now it's reading about 68 Fahrenheit temperature, and that's basically a little bit chilly in this room, and it should increase the LEDs if it reaches 72. So I'm gonna try using the candle, hopefully without burning the PCB. But as you see, it went up to over like 74 right now, 75, and the reflections on the LEDs are already incremented. If I take this up, it will take, here you go, and it's already going down now around 171, 70. And I'll be showing the measurements on the screen. So as you see, our application is running on the system and it's collecting the measurements for the 4 sensors as our network is still running. Thank you very much for watching.